Okay, where is the rest? Mana yang lain ni? Baru 14 orang. Okay, try buat 3A dulu tau. Once you guys are done with 3A, tekan nombor 1 di chat box. Okay, I'm sure done very good. Okay, I'm sure you may proceed with 3B and 3C. Okay, mana yang lain ni? Kenapa tak masuk Google Meet, Miss? Okay, Fahmi dan Shani dan semua makan mochi. Hmm? Hmm? Kalau beli ya. Hmm? Okay, once you guys are done, tekan nombor 1 di chat box here only for 3A. Okay, baru 7 orang siap. Masih tunggu lagi. Pada yang dah siap tu boleh main proceed with the next question, okay? So sweet of you. Dah. Zula minta. Hmm. Oh, maybe dia nak soalan yang macam ETS ni kot. So takkan macam bila buat together. Okay guys. Okay, 1 more minute. Then lepas tu Miss discusskan korang So majority macam dah siap. What about the rest? Boys, where's Amir? Amir hari ni? Nabil dah siap ke belum? Okay, now boleh Miss discuss? Boleh. Okay, ada yang share screen, share device ke? Miss nak tanya, ada yang share device ke? Okay. Alright, so now let's discuss. So dia cakap, a 15 volt battery. So 15 volt battery ini, apa dia? Adakah dia EMF ataupun potential difference awak?
EMF.
Very good, EMF. With internal resistance. Okay, remember, internal resistance kita tulis dia sebagai R kecil. Connected to a resistor of 13 ohm. So, connected to a resistor of 13 ohm. Okay, the first question. Calculate current that flow in the circuit. Okay, so what formula should we use to calculate the current flow in the circuit? Anyone? Nak pakai formula apa tu?
Itu I bracket R plus R kecil.
Very good. R plus R. Okay. Very good. So our EMF is 15 volt. We are looking for the current and we know the resistor is 13 ohm and the internal resistor is 2 ohm. So you press your calculator, you will get the current of 1 ampere. Okay, so we are done with question 1. Okay, let's look at question 2. Mula dah. Calculate the terminal voltage of the battery. Sekarang kita nak cari terminal voltage of the battery. So what formula should we use to look for the terminal voltage of the battery? Nak pakai formula apa tu?
V equal to EMF minus IR.
Correct, kan? So maksudnya kita akan pakai yang formula ni, EMF equals to V plus IR. Which is your EMF adalah 15 and then kita nak cari V dan current kita adalah 1 dan internal resistance kita adalah 2. So tekan calculator, awak akan dapat 13 volt. But you have another way to solve this question by using Ohm's law. Okay, which is V equals to IR. Okay, your current is 1 ampere and your resistor is 13 ohm. So you will get 13 volt. Okay, we are done with question number 2, A2. Now, Miss ke hati je tulis macam ni. Sekejap So this is 1, 2 untuk A. Okay, now untuk question A3, the question asks us to calculate the power dissipated. Jadi kita nak cari power dia. Kalau nak cari power, nak pakai formula apa? Berapa
P
formula?
IV.
Sorry, Hakim, ulang balik kami. P equals to?
IV.
IV. Very good. So P equals to IV. Kita juga boleh pakai formula P equals to I squared R. Dan kita juga boleh pakai formula P equals to V squared R. Use either one. Not a big problem. So okay, Miss pakai yang ni. P equals to IV. Current kita dah tahu satu. And then kita punya voltage adalah 13. So kita akan dapat 13 watt. Remember, unit untuk power adalah watt. Okay, very good. So we are done with question 3A3. Okay, now let's proceed to question 3A4. So the question asks us to state why. Kenapa? Terminal voltage of a battery is usually lower than EMF. Kita tahu kan EMF kita nilai dia adalah lebih besar daripada kita punya terminal voltage of a battery itu. Why? Kenapa korang rasa dia EMF kita lebih tinggi daripada terminal voltage kita? Due to what? Anyone?
Internal resistance.
Very good. Due to the internal resistance. So awak boleh tulis macam ni saja. Energy is dissipated as heat in the internal resistance in the battery. So kita tahu internal resistance itu berada di dalam battery. Okay, for example, I have a circuit. Okay, I have a circuit. Lepas tu maybe misalkan ada satu resistor sini. So sekarang V ini adalah terminal voltage across the EMF lah. So ini adalah terminal voltage dia. Dan ini adalah EMF. So dalam EMF ni dia akan ada internal resistance. Okay. Sebab itu EMF awak reading dia adalah lebih besar daripada terminal voltage. Why? Sebab some energy already been lost here due to the internal resistance di dalam battery ini. Okay, kan? So distribution of marks. This is 1 mark. 1 mark. 1. Sudah 3 kan? Ini adalah another 1 mark. 4 marks. Okay. So awak akan ada markah untuk substitution. So substitution awak akan ada markah. So you will get 6 marks. 1, 2, 3, 4, 5, 6. Okay. Alright. Miss nak tanya, siapa dapat full marks? Okay. Siapa yang dapat full marks tekan nombor 1 di chat box. Okay. Siapa yang dapat below dan 4 marks tekan nombor 2 di chat box. Full marks tekan nombor 1, below dan 4 tekan nombor 2. Very good. Okay, good job guys. Okay, good. Okay, good. So, I hope you know siapa yang salah, ada tersalah sikit, it's okay. We are still learning. Kita bukan tengah buat PSPM lagi. So, you make sure to know where you get it wrong so that you can improve it on our next exercise question and also during PSPM. Okay, now let's try B. Okay, Miss bagi masuk untuk try B. Okay, once you guys are done trying B, tekan nombor 3. Okay, dah siap B, tekan nombor 3. Oh, okay. Alright. Siapa yang dah siap B, boleh try C. Okay, to those who already done with B, you may try C. I'll give you around 2 minutes to 3 minutes to try B, then we're going to discuss. Kita tengoklah laptop. Kita ni nak update. Okay. Okay, now let's discuss. Boleh ke Miss discuss?
Boleh.
Boleh. Okay, baiklah. So, kejap, give me 1 minute je. Okay, dia cakap a platinum wire has a resistance of 1.5 ohm. Okay, at 0 degrees Celsius. So, maksudnya ini adalah dia punya initial temperature. So, ini adalah initial resistance dia juga. The question asks us to calculate the wire resistance at 20 degrees Celsius. So, waktu final dia. Okay, kita nak cari R final kita lah. If the wire temperature coefficient of resistance adalah 3.92 times 10 to power of -3 per degree Celsius. So, Miss nak tanya, temperature of coefficient, apakah simbol dia? Anyone?
Alpha.
Alpha, correct. It is alpha. So, sekarang kita nak cari R dia. Kalau kita nak cari R at 20 degree Celsius, kita nak pakai formula apa? Korang pakai formula apa untuk cari R dia?
R equal to R naught bracket 1 plus alpha change of temperature.
Very good. R equals to R naught 1 plus alpha change in temperature. So sekarang kita nak cari R kita. R naught kita waktu temperature dia 0 degree Celsius adalah 1.5. Okay, 1 plus alpha kita adalah 3.92 times 10 to power of -3. Dan kita tahu kalau change in temperature, maksudnya dia adalah final temperature tolak dengan initial temperature. So, ini dikira macam kita punya initial temperature jugalah, T0. Okay, so final temperature kita adalah temperature yang kita dah tahu iaitu 20. Initial kita adalah 0. So, tekan calculator, you will get the answer of 1.62 ohm. Okay, boleh?
Boleh.
Okay, so there are 2 marks. So, bila 2 markah, so this is the first mark yang you akan dapat and this is the second marks. Okay, so siapa yang dapat kedua-dua markah ini betul, tekan nombor 1 and make sure your final mark ada unit. Okay, tekan nombor 1 if you get both answer correct. I mean like the substitution and also the final answer correct. Okay, very good. We kena, dah lah. Okay ke kalau kita? Kasi aku belas. Aku stress free. Ke better now? Okay, chill. Kita kesian kau. Kesian kau lagi laut. I feel so bad you need to walk there. Apa? Okay. Wait. Tak record. Lepas tu tadi dah lah kelas record meeting macam mana. Ada F44. Okay guys, let's discuss. Give me a moment. Okay, now let's discuss. So a potentiometer consists of a uniform wire AB length of 100 centimeter. So you have a wire length of 100 centimeter. So this is length for AB. So a balance point is found at 60 centimeter from point A. So from point A, maybe here 60 centimeter. No, it should be around here. So 60 centimeter. So this is at point from 60 centimeter from point A, a balance point is found. So maksudnya dekat sini, dari sini length dia adalah 60 centimeter. Tetapi kita tak tahu EMF dia berapa. So Miss Label dia bagi satu-satu. And then soalan tu cakap lagi. Lepas itu, tetapi kalau awak guna EMF of 1.5 volt, balance point itu adalah 30 cm daripada point A. Okay, so ini adalah 30 cm. Ini adalah EMF 2. Okay, EMF 2 kita dah tahu. Dia dah bagi EMF 2 dia dah kasih 1.5 volt. So the question asks us to calculate the unknown EMF. Okay, so what does it mean by balance point? Anyone? What does it mean by balance point? Apa maksud balance point? What happened dekat balance point tu? What happened? Anyone?
The potentiometer is balanced.
Very good. Potentiometer is balanced. So when potentiometer is balanced, that means no flow of current because your potential difference is the same. So meaning your current dekat you punya reading of the galvanometer is 0. So you nak cari EMF 1 kan, you can straight away use this formula. EMF 1 over EMF 2 divided by length 1 divided by length 2. So EMF 1 we are looking for it. EMF 2 is 1.5, length 1 is 60, length 2 is 30. So you will get your EMF 1, 3 volt. Okay, 3 volt. So now question 2. Okay, question 2 dia cakap, calculate the resistance of the wire AB. So we know we have the wire AB here, right? So dia minta kita calculate the resistance in the wire lah. Sebab remember, untuk potentiometer dia takkan ada resistance, but they will be resistance inside the wire. So wire tu yang ada resistance. So resistance, so the question asks to look for the resistance where we know the cross-sectional area is 2 millimeter square, the area. And also the resistivity is 1.7 times 10 to the power of negative 8 ohm meter. And we know the length of the wire is 100 centimeter. So what formula should we use to find for the resistance? Anyone? Formula apa kita nak guna cari resistance?
Resistivity equal to RA over L.
Very good. So resistivity equals to RA over length. When we rearrange this equation, we will get resistivity darab dengan length over area. So we know the resistivity is 1.7 times 10 to the power of negative 8 and the length of the wire AB is 100. So 100 times 10 to the power of negative 2 and the area is 2 millimeter squared. So macam mana Miss nak tukar 2 millimeter squared kepada meter squared? Anyone? How? Macam mana Miss nak tukar?
Darab 10 kuasa negatif 3 lepas tu kuasakan 2.
Very good. So we know millimeter to meter adalah 10 to power of negative 3. And then kita tahu dia ada square. So kita kena squarekan dia di sini. So awak akan dapat 2 times 10 to power of negative 6 meter squared. Very good. So 2 times 10 to power of negative 6. So you punya resistance, you will get the answer of 8.5 times 10 to power of negative 3 ohm. That's all. Okay, so what about the distribution of marks? So distribution of mark will be 1 for the substitution, 1 for the final answer, substitution, and final answer. With unit, final answer with unit. Without unit, your answer, you will not get any mark. You will get 0. Okay, may I know who got it correct? Siapa dapat full mark 4 markah? Tekan nombor 1. Siapa tak dapat full mark? Tekan nombor 2. Okay, very good. Okay, once you guys are done, you may try with this question. Okay, yang ini mesti tak bagi lama ya. Okay, very good. Okay, good. Okay, once you guys are done with question C ni, tekan huruf Y di chat box. Mesti akan bincang. Okay, very good. Sinjay, so you may proceed to another question. Kami sudah hantar folder soalan tu dekat dalam group Telegram. So kalau awak dah habis dengan soalan ni, awak boleh proceed to the other question. Kenapa? Hmm? Okay guys, tolong try jawab soalan soalan quiz Google Form yang pre-PS tu tau. Okay, I'll give another 2 minutes for everyone to try, then we can discuss. So once you guys are done, you may proceed with the other question. Sejuk gila. Okay, now let's discuss. So, figure 3 shows a circuit with a battery having an EMF of 12 volt. So we know the EMF is 12 volt and also the internal resistance of 0.2 ohm. So this is the battery and we have the EMF of 12 volt and internal resistance of 0.2 ohm. And they are connected to two resistors which is 3.3 ohm and 2 ohm. So resistor 1 and your resistor 2. So the first question asks us to calculate the current in the circuit. Okay, so what formula should we use to calculate the current in the circuit? Anyone? Kita nak pakai formula apa?
EMF equals to R plus internal resistance.
Very good, Sinji, correct. So the EMF is 12 volt and we are looking for the current. Okay, now for the resistance, we need to look for the effective resistance first. So now, cuba tengok R1 and R2 is in series or parallel?
Series.
Series, right? So cari dulu R effective dia adalah R1 tambah dengan R2. So R effective equals to 3.3 plus 2 which equals to 5.3 ohm. Now you already get the 5.3 ohm plus with the internal resistance of 0.2. So you press your calculator, you will get the current is 2.18 ampere. Okay, can? So 1 mark for the substitution, but the substitution mark you need to get, you must show the calculation for the effective resistance and another mark for the current. So if you tak tunjuk calculation for the effective resistance, if you buat macam ini, 12 equals to I, 3.3 plus 2 plus 0.2, acceptable as well. So no worries. So it is acceptable as well. Okay, or okay, then only you can get 2 marks for this question. Okay, so the next one is calculate the terminal voltage across the battery. So we need to calculate the terminal voltage V. Just now we already calculated the current. So what formula should I use to calculate the terminal voltage? Anyone?
V equals to IR.
Very good. V equals to IR. So I dia adalah kita dah tahu kan I dia adalah 2.18 and the resistance is the effective resistance which is 5.3. So tekan calculator you akan dapat 11.56 volt. Okay, so 1 mark for this and 1 mark for answer with unit. Or kalau ada yang buat cara ni pun diterima, which is EMF equals to V plus IR. Your EMF is 12 volt. Your V is 11.56. No, we are looking for V. Sorry. Okay, V adalah V. Current you adalah 2.18 and your internal resistance is 0.2. So you rearrange the equation and press the calculator, you will get 11.56 volt. So tak kisah. Either that way or this way. We can use the first way or the second way. Up to you guys. Both method is acceptable in exam. As long as you put the substitution and also with the correct answer and unit, then you can get the full mark. Okay, so to those who get the full mark for C, press 4 in the chat box, please. Very good. Siapa yang dapat kurang, tekan berapa markah yang awak dapat. Okay, that's great. So this is like, okay, kalau tengok, kalau dalam exam kan, ini adalah satu soalan untuk chapter 3. So chapter 3 je dia tengok, dia ada berapa banyak markah kalau you betul. 6 tambah 2, 8, 8 tambah 4, 12, 12 tambah dengan 4, 16. Senang-senang sahaja you dah dapat 16 marks, okay? Full marks dah. So, this will be really helpful. So, this is how you answer PSPM question. Because kalau PSPM question dia adalah subjektif, you memang kena tulis semua ini. That's why practice yourself to write the formula. Even though you know how to solve the question immediately, write the formula, write the substitution, write the final answer with the correct unit. Okay. Okay, now, so today for the last question, this one. Okay, try to answer this one. Okay, once you guys are done, nak tekan huruf apa pula? Okay, press H dekat dalam chat box. Okay, good. So, Sinji dengan Balkis Patricia, you may try chapter 1 question. For chapter 1 question, nanti Miss hantar video, okay? Okay, so for this question, Miss akan bagi hint. Okay, macam mana kita nak open circuit ini untuk bagi faham. Okay, first of all, bila awak dapat circuit yang sengit-sengit macam ni, lukis daripada bateri dia dulu. Okay, so kita Miss draw macam mana? Okay, so Miss dah draw yang ini Okay, waktu Miss draw tiba-tiba, tengok ni, alamak ada simpang. So maksudnya simpang dia tu sengit. So sengit tu maksudnya dia adalah parallel. So dia ada simpang kan? So settle. So Miss dah lukis yang ini. Okay, lepas itu memanglah Miss kena lukis yang ini, dia bersambungan. Tapi sebelum dia bersambungan dengan ini, dia akan ada yang atas ini dahulu. So yang atas ini, dia akan jadi macam ni. Okay, lepas itu baru dia ada simpang balik. So dia ada simpang balik, dia akan jadi macam ni. Then this is the final one. So this is how you open the circuit. So misalkan label sini R1, R2, R3, R4. Remember, bila kita nak cari effective resistance ataupun equivalent resistance, kita kena solvekan dia daripada jauh daripada terminal. Dan jauh daripada your potential difference ni, okay? Jauh daripada dia. So kat sini akan jadi R1, R2, R3 dan R4. So this is your diagram, your first diagram. Okay, misalkan tunggu lagi yang lain. Sebab baru 3 orang je yang siap. Okay, I'll give you another 1 minute, then we will discuss. Okay, let's discuss. So now, bila kita nak solvekan dia, kita akan solve dia jauh daripada ni. Okay, so sekarang Miss nak tanya, R1 and R2 is parallel or series?
Parallel.
Very good, parallel. So bila dia parallel, Miss nak tanya, formula untuk parallel apa?
1 over R1 plus 1 over R2.
Very good, 1 over. Okay, so Miss faham sebab dekat exit ticket Miss baca banyak lagi yang confused mengenai formula ini tertukar dengan capacitance. So jangan tertukar tau. Okay, so R1 kita adalah 9 dan R2 kita adalah 7. So tekan kalkulator, awak akan dapat your R1 to 3.94 ohm. Okay, settle. So Miss akan place my second diagram. So macam Miss cakap, just draw the diagram so that you will understand better. Tak payah nak draw cantik-cantik sangat, tak perlu nak pakai ruler. Tengok macam mana Miss draw. Hodoh-hodoh sahaja. So dekat sini kita dah gabung dia, so dia akan jadi R12. Dekat sini adalah R3 dan dekat sini adalah R4. Okay. So now, Miss nak tanya, R12 dengan R3 series or parallel? Series. Very good. So kita tahu kalau series kita hanya tambah dia sahaja. So R12 tambah dengan R3. So R12 kita adalah 3.94 dan R3 kita adalah 5. So you akan dapat 8.94 ohm. Okay, done. Okay, so the third diagram. So this is the final one. Kita nak combinekan dia. So lukis je, tengok macam mana Miss lukis. Tak cantik pun. So this is your untuk R4 you. Dan ini bila kita dah gabung, dia akan jadi parallel dekat sini. So R1, 2, 3, R4. So last dia, dua ini adalah parallel. So bila parallel, kita akan dapat 1 over R effective equals to 1 over R1, 2, 3 tambah dengan 1 over R4. So R1, 2, 3 kita adalah 8.94 dan R4 kita adalah 2. So you will get your R effective, which is 1.63 ohm. That's all. So this is the final answer. So what is the distribution of mark? 1 mark here, 1 mark here, and 1 mark here. Okay, next question. Dia minta kita cari current. So macam mana nak cari current? So nampak tak dia minta kita cari current I ni. So dia minta total current. So macam mana nak cari total current? Anyone? What formula should I use?
Equal to IR.
Equal
to IR.
Okay, total voltage equals to total current darab dengan total resistance ataupun kita kata effective resistance. So dia tahu total voltage dia adalah 12 dan effective resistance dia adalah 1.63. So you akan dapat you punya total current 7.26 ampere. Okay, boleh? Yep, that's all for today. Okay, do you have any question, kids? Or okay? Okay, so if no question, just wanted to let you know, tomorrow we will have class. We will be going to do revision on UPS. So please wake up at 8. Our class will be at 8. Okay? And if you don't have any question, you can fill in this Google exit ticket. And that's all from me. Give me a moment. Oh, before Miss nak lepaskan korang, Miss nak tanya, siapa dapat full marks? 4 markah ni betul. Tulis nombor 1 dekat chat box. Okay, great. Okay, that's good. Okay, very good. Okay, good. So kalau PSPM punya paper macam ni, best kan? Okay, now kids. Okay, you may fill in the Google form and that's all from me. Thank you so much everyone. Bye-bye. Assalamualaikum.
Thank you.
Thank you, Miss.
Okay, you're welcome.
Thank you.